Welcome. Up until now, we've only talked about projectile motion off the edge of a cliff. Today we're going to talk about projectile motion on flat ground. So in other words, what would happen to an object such as a soccer ball that's kicked across the field? The motion that it takes is the motion that we're going to look at today. So let's get started. Imagine we're on flat ground and we kick a soccer ball at an angle of 30 degrees to the horizontal with a speed of 25 meters per second. Again, just like before, we want to find the range of the soccer ball. So just like before, we want to look at both our x and our y directions separately. And so the first thing we want to identify is our velocity, initial velocity in the x direction. And for simplicity's sake, because we'll have two different velocities, I'm going to use subscripts x and subscripts y so they don't get confusing. Our velocity in the x direction is simply the x velocity of this vector, which we can find with hypotenuse cosine theta. So our Vx will equal 25 cosine of 30, which equals 21.65 meters per second. Similar to before, our acceleration in the x direction will still be 0 because there's still no forces in the horizontal direction that are speeding it up or slowing it down. And then the range is what we're looking for, which is also horizontal. Now we can look at our vertical direction. Again, we have to find our vertical velocity, which can be found using hypotenuse sine theta, which becomes 25 sine of 30, which equals 12.5 meters per second. Just like before, our acceleration in the y direction is gravity, but because our object is initially traveling upwards, we have to use a negative 9.8 meters per second squared. And then we have no distance information in the vertical direction. So, just like before, the key to this problem is to find the time. And similarly, time is still based on the y component. So, we can find our time by thinking about our object as if it is only going up and down. Rather than the horizontal motion that it has, let's instead just imagine that it's an object that goes up and then falls straight back down, where its initial velocity there equals 12.5 meters per second. We want to know the time that it's going to take to go up and come back down. And we can do this by realizing that its final velocity here at the very top is going to equal 0 meters per second. So we can find its time by saying Vf equals V naught plus AT. And we solve for t, and this becomes Vf minus V naught over A. When we plug in values, our final velocity here is 0 meters per second, while our initial is 12.5. And our acceleration, as we noted before, is negative 9.8. These two negatives cancel out, giving us a positive time of 1.28 seconds. But we have to realize that that is just the time that it takes to go from our initial position to our final position. So we must multiply this time by 2 to get our final time, which is equal to 2.55 seconds. So this is our total time of flight from the very beginning to the very end. So just like before, we take our time and we move it over to the x-axis. So time equals 2.55 seconds. And we can use the same formula as before of range equals velocity in the x direction times time. So we plug in our x velocity that we calculated at the very beginning of 21.65 times the time of 2.55 seconds. This gives us a total range of 55.23 meters. And that is the total distance that our object will travel with these given conditions. The second thing that we want to do is we want to calculate the maximum height that our object has. So we want to find this height right here that it has when it's at its maximum peak, right there. And again, we can do this by thinking of our object not as something that's going in both the x and the y direction at the same time, but instead an object that's just going up and then coming back down. And so we want to find this height right here, h, where we know that our initial velocity that it was thrown with equals 12.5 meters per second. And again, its velocity here, f, is 0 meters per second. So we can find height by first finding time. And we can find time that it takes to go from this starting position to this finishing position in the same way we did over here. In fact, we did already find the height that it takes to get to its highest point right there, which was equal to 1.28 seconds. So we can use that again and say that our time equals 1.28 seconds to get to the highest point. And then we can calculate our height of 1/2 at squared, where our height will just equal 1/2 times 9.8, which is gravity, times our time of 1.28 squared. This gives us a maximum height of 6.53 meters. So that will be its height at its highest point exactly halfway through the trip.